Yep. Hello everyone, welcome to Karpenter SIG Autoscaling SIG for Monday the 31st of July 2023. We have Maciek is going to give us effectively a companion walkthrough of the cluster autoscaler to go with the Karpenter API one we had last week. I think that's the only topic we currently have on the agenda. So Patrick, if you want to take us away.
Sure. If you give me a second to figure out how to do the presentation, one second. Right. Okay, is that working? I only have one monitor, so in this setup, so I can see you and see the doc at the same time. So
yeah, can see the Google Doc.
All right, great. So I basically have a summary here of all the what I would consider API surfaces of Cluster Autoscaler. I don't think that's going to take very long time because there isn't that many, I think, that are interesting. I didn't want to do a more sort of generic Cluster Autoscaler tech talk or anything of the sort, but if anyone has any question or if there is any aspect of it that is in any way interesting or helpful, I'm happy to try to answer. So please stop me at any time with any questions. And ideally, if you ask verbally, because when I look at the doc, as I mentioned, I have single monitors, I will not see hands possibly. So starting very quickly, I think there are a few notes I wanted to make. So I think the current state obviously is not ideal, but that's what it is. I think more interestingly, I think the scope of Cluster Autoscaler is different from Karpenter, as we already discussed last week. And this is for a few reasons. One of them is that the job that Cluster Autoscaler is doing is much more narrow. I would say it's basically limited to resizing pre-configured node groups, and then what those node groups map to and how they are configured at a given cloud is outside of the scope of Cluster Autoscaler. One thing that is misleading with just saying it resizes node groups is when it's removing nodes, it's removing specific nodes. It's resizing them when going up, but really just deleting specific nodes for scale down. And managing Kubernetes node objects is also not in scope today, at least. And neither is configuring nodes, setting any sort of, I don't know, labels, annotations, anything, with the exception of like draining the nodes and so on as part of the scale down. We also soft taint or like preferred taint the nodes that we consider for scale down, just to reduce the chance of something scheduling there. But this is again just kind of part of the mechanics of the scale down rather than some sort of configuration of nodes. And I think moving on to APIs we have, I think the most obvious and sort of visible API surfaces is annotations and other similar things. So we have a bunch of pod level annotations and also some taints, or specifically taint prefix. Actually, both with annotations and taints, we have some prefix mechanism. So basically, there is a prefix, and then any taint that has a particular prefix has a specific semantic. And similarly, with there is going to be a node annotation that works in a similar way. I think actually the pod level annotations are possibly something we may look to standardize on, because I think a lot of those could potentially make sense in Karpenter world. I don't know if annotation is the best way. Maybe a field-in API would be better. But anyway, what we have today is basically the save to evict annotation, which is by far the most popular one, and it just prevents pod from being restarted during scale down. potentially blocking the scale down. It also explicitly allows this pod to be restarted even if some of the other conditions are not met. If you set it to the opposite value. There are some annotations that allow controlling some eviction-related settings, particularly related to daemon sets. So whether a pod should be treated as daemon set pod, even if it's not managed by daemon set, and whether it should be evicted. Some daemon sets is better to evict, some apparently it's better not to evict. So this is pod level, and then for the node level, we have option to basically block deleting a particular node, or delay deleting a particular node. So it's purely scale down control. And this is all the annotations that exist, I think, for the general cluster autoscaler, but certain providers have added their own, and there is quite a few of those. In general, I think maybe one thing I forgot to mention is, I think compared to Karpenter, maybe cluster autoscaler in many ways is operating a lot like a framework for building autoscalers by particular providers. So actually a lot of API surfaces we have is going to differ by provider, and more common surface or like API surface that we maintain is going to be Golang interfaces that are just used for building providers and customization. I'm not covering those here because they are completely internal, obviously, to implementation. But if there is any interest, I'm happy to go into details.
I know Jack has had his hand up for a couple minutes. You might not be able to.
Sorry, I missed that.
Yeah, if this is a good time to interrupt you about scale down, I'd love to ask some questions, a little more follow-up about that. So specifically around I think you mentioned that cluster autoscaler doesn't pick any particular nodes as the scale down candidate. Does that get deferred to the provider, or did I mishear that?
No, so
for example, I'm just thinking of in an environment where you've got like n number of nodes and they're sort of obviously not balanced. Then you would want, there should be like an obvious path to sort of optimize which nodes to scale down without thrashing, without draining a node that has a bunch of pods, so that it forces rescheduling onto another node.
So I maybe was speaking not very clearly. No. So it absolutely does select specific node. The semantic is basically delete this specific node or none at all. So I meant this is kind of confusing because a lot of people think of cluster autoscaler in terms of resizing. So when we scale up, it's basically just resize the node group because we just add 3 nodes. They don't necessarily need to be specific ones. When deleting, it's absolutely deleting a specific one.
That's right. That makes sense. So the interface, the sort of generic interface for scale up is just increment the replica count, which is going to be slightly different from provider to provider. And then the interface for scale down is delete this set of nodes. And then the replica count, all that, the details of how that replica decrement happens is going to be different from provider to provider, like,
Yes. Yeah. So it's basically, there is an expectation for how how the semantic should behave in terms of, it's literally adding a provider is either implementing a Golang interface or implementing a gRPC interface, which I have below in my list. And so there is an expected semantic of basically, if we call delete node from cluster autoscaler, if that node doesn't exist, for example, the expectation is that nothing happens rather than a random node is deleted. But then how this is actually implemented by a given provider is entirely up to them. For something like, say, ASG, it may be just a matter of calling a method on the ASG. But there are some providers which doesn't necessarily map as directly to some underlying cloud provider concept. In principle, you could manage raw VMs that way if your provider was just creating the VMs on its own and then deleting them.
Well, yeah, that adds some clarity. I mean, in practice, I've observed lots of times that if you have, let's take a simple cluster of 10 nodes whose pod capacity is 300, say 30 per node. If I empty all 30 pods from one node and it's running cluster autoscaler, I'll see that node disappear.
Correct.
I think that there is some I'm not sure to call it subtlety. I'm not sure exactly what would happen if I say empty 30 pods, if I empty 3 from each node. So now the cluster is running at a capacity where we can lose a node, but there's overhead for 3. And I know that I'm simplifying this thing greatly because you're not going to want to cap your nodes at 100% capacity. But in that type of situation, it seems that Karpenter has more sophisticated ways to kind of rebalance and optimize for density over time compared to cluster autoscaler. But that also might, again, there's so many providers in cluster autoscaler that I don't fully understand exactly what's core to cluster autoscaler and what some of the providers are sort of adding as, I don't want to say value add, but that kind of behavioral value add on top of the core concepts.
So in terms of like specifically scaling down, there's basically 2 modes of scale down, and that's called cluster autoscaler. I'm not going to go unless explicitly mentioning that. What I'm saying is called cluster autoscaler and not specific provider.
Yeah, that's
there
right.
are 2 basic ways of doing scale down. So there is scaling down empty node, which is if the node is completely empty, and then there is scaling down underutilized node, which is basically cluster autoscaler doing simulation. I think this is actually maybe kind of similar to how consolidation works in Karpenter. It's basically doing a simulation of whether the pods will be able to run on some other node, and if so, it can delete one of the nodes. It's going to go evict the pods and then let them reschedule on other nodes and then delete this node.
We have both of those methods. There's one more essentially, which is a simulation that would replace a current node with a cheaper node. We pre-spin that node and then do the eviction. So it's kind of like a replace. We have the delete case, which is all the pods would schedule elsewhere, and then there's the replace case, which is includes essentially recycles the capacity for or resizes the capacity in a sense.
So I think cluster autoscaler has 2 out of 3 basically. It doesn't have the last one you mentioned.
Cluster autoscaler should be able to implement that too. Like that's something that, like you have all the options of things that you could spin up, and if it's essentially migrate from this node group to that node group, or replace potentially 2 nodes from these node groups to 1 node in that node group, or different types of moves that could be done.
You could probably, so the part I mentioned about cluster autoscaler being framework, like a lot of things that Karpenter does, you could actually implement even as an extension to cluster autoscaler these days. That may not have been true a few years back, but now there is so many ways to extend it that I'm pretty sure you could implement that if you wanted to, as just by doing extensions. I also think, I'm not entirely sure, you could actually run cluster autoscaler as autoscaling layer on top of Karpenter. You could probably have Karpenter as a cloud provider implementation for cluster autoscaler. I'm not saying this is necessarily what you should be doing. Just technically, I think you could implement a node group as a Karpenter provisioner, and that I don't particularly see why it wouldn't work.
Yeah, I mean, we talked about this last time actually, was that we have the machine API, which we've talked about renaming to node claim, just for your own visibility. But it's essentially a request for a node, and you could absolutely use that as kind of the underlying lifecycle primitive. That it's almost like the difference in that's kind of the remaining bit of responsibility, where like Cass has the Karpenter has that Cass doesn't, which is the node lifecycle stuff. And yeah, you could absolutely build the Karpenter provider. Hey, I wanted to pivot. I had a question on the daemon set pod stuff, enable daemon set eviction. One of the things that we realized when implementing this was that daemon sets are not, we don't actually have to consider daemon sets on eviction. The thing that we care about is whether or not the pods implement the toleration for not ready, the no schedule and no evict toleration. And so we can essentially assume that if those pods do tolerate those, or what we do is we assume that if the pods are tolerating those, then the scheduler, whatever is managing that pod, is going to cause it to come back, which is going to cause it to reschedule. So we shouldn't even bother evicting it. Mm-hmm. And so for any daemon set that does happen to tolerate its pods, and most of them do, that kind of falls under that category. But then there are some daemon sets that only that after like, if you coordinate the node and then drain the data set, the pods won't come back. So we use essentially that to classify. I'm kind of curious if you guys have run into other cases, or is there something that we're missing? Because this is kind of, I think, one area where we've diverged in our implementation and in our interface for how that works.
Yeah, I think this is a very interesting point. I think it's maybe separate from the bigger discussion on standardization. I would love to be consistent here. And actually, there is an ongoing discussion about this, because there is also some drain logic in kubelet, I think. And there is an ongoing discussion about standardizing this with cluster autoscaler. I don't have a link right now. I can send it, like, or maybe I'll put it in meeting notes afterward. I don't want to start searching for links right now. But there is an ongoing discussion, and I think there is more complexity in there in terms of, apparently the order of daemon set eviction is sometimes relevant. So it's not just do we evict or do we not evict. There is some cases where it's important in terms of the order in which we evict. So there is, I think there is some like note, I think somewhere in like SIG note, there has been some discussion on this, and they decided to drain by pod priority. And I think there is ongoing work to sort of make cluster autoscaler just, there is a cap on this basically. And then the idea is basically, let's just implement the cap in cluster autoscaler and be consistent with how other parts of Kubernetes do this. But there is an ongoing discussion. So if there is any interest, then maybe that would be a good place to do this, because that apparently goes beyond just cluster autoscaler and Karpenter.
It would be pretty sweet if you could taint a node with a well-known taint, and then the node lifecycle controller does the coordinate drain for you and follows all these rules. And that would just be a core upstream feature.
Yeah, that's, I think, a possibility. I don't think there is any made decisions there. I think there's literally a discussion right now. There's, suggestions on whether it should be done by one controller or whether it should be just one implementation of in some library, some Kubernetes repo, and then you just import that and use at least a single implementation. I'm honestly not involved in this particular one. So I know there is discussion. I just don't know what the consensus is or whether there is one yet. But I'm happy to add a link. So if there is any interest, that's kind of a thing that just makes everyone's life easier. I think if there is one way of doing this, that is.
Well, the best API convergence in my mind is deleting the API surface or deprecating the API surface, because we can replace it with something generalized or non-configurable. The other question I had just from this section was around status taints. So we've run into startup taints, we implemented that. I think it's the same concept, but status taints, can you elaborate a little bit on what those are and what the use cases were you found?
Sure. So the three types of taints that we have, I think, or that we think about is the, again, startup taint is the, as you said, already exists in both. There is the other two use cases is either you have a permanent taint, so maybe you use your taint to control where your pods are running, as in I have some specialized hardware, like GPU would be a good example. I have this expensive hardware, I don't want random pods running here. I'm just going to put taint in here and then not let anything else in. So this is a taint that is expected to exist for the entire duration of node lifecycle, and it's purely kind of a scheduling tool. And then a status taint would be a node that is maybe experiences some problem, like there is a status condition that is not part of Kubernetes status conditions. Like for some reason, it should not temporarily be used. And because in cluster autoscaler, generally speaking, we use existing nodes as a template for how new nodes will look like, then the distinguishing if the state is permanent or temporary is important, like because it really tells us whether the new node will have this state or not.
Got it. So like CPU pressure, memory pressure, because we're not using the node as the authority for those taints, we don't need to consider it because our taints are essentially defined on some API surface elsewhere, but there's no user defined concept of this is a status taint or not. Or I guess I guess they do have to define it because there may be custom status taints, and cluster autoscaler needs to be aware of that.
Yeah. So I think basically, in a way, I feel. So I may be getting this wrong because I think my expertise with Karpenter is limited, but I think it's basically there are 3 types of taints, and you sort of explicitly define 2. So you define startup taints and then taints, which is going to be those long running taints, and then status taint is whatever anyone just uses kubectl taint to put, or like whatever other Kubernetes client. But Karpenter doesn't need to know about this because it knows about the 2 other kinds, and those are the relevant ones. So for cluster autoscaler, it's sort of the opposite. Like it still divides them into 3 categories. It's just it needs to know like you mark startup taints and those status taints, and you don't mark permanent taints. So it's kind of the same. I think 3 sets. It's just in both cases you specify 2 out of 3. It's just you specify different 2 out of 3, if that makes sense. And then the third set is basically whatever is left, of course.
Yeah, makes sense.
All right. Let me move on. So the next one, and this is basically just something I wanted to flag. There is an ongoing CFD API proposal that is in API review to introduce something called provisioning request. So it's a CRD API where you will be able to basically request nodes to be pre-provisioned. For use cases such as batch, where maybe you want to have all of your nodes pre-provisioned before you run a job, like queuing use cases. And I think also as a kind of over-provisioning mechanism. So the idea is basically you're going to be able to create a CRD and specify the extra capacity you need. Like I need to be able to run, like have enough capacity to run that many pods with that pod spec. And then Autoscaler provides this, and then you can consume it later on. The cap has all the details, so I think it would be cool if there is interest, if you commented on whether this also makes sense for Karpenter, and if there is any interest on your side. I think that would be pretty cool. And the good news is it's still in API review, so it's very good time to make any changes. I think on high level, because it's all kind of about create capacity for this set of pods, and because both Karpenter and Cluster Autoscaler operate on pods naturally, it should be maybe reasonably easy to implement. But again, I'm not sufficiently familiar with implementation.
We've been debating this use case generally as to whether or not it should be a pod-oriented use case or a node-oriented use case. There's obviously the negative preemption pods, which I think this is essentially codifying that use case. Like I want to drive the autoscaler with pods, but I don't want the actual pods to exist in my cluster because it pollutes my dashboards and generates extra events in the cluster, et cetera. Is that roughly the reason why you guys are moving to an API for it as opposed to just using negative preemption pods?
Obviously, those preemption pods are also used commonly. I'm not the one driving this. I think there is some additional stuff that can be done because it comes in big bunch. So if you just add preemption pods, it's easier to guarantee they get maybe identical nodes or stuff like this. Like that, you can do things with atomicity because it's a single CRD, and that is relevant for kind of batch use cases where you may want all or nothing semantics, and that is much easier to do. So I think this may be also one of the reasons, but certainly kind of problems with pod preemption. I also, in my experience, the pod preemption is great until a certain amount of pods. There is an amount where basically scheduler is going to get stuck doing the preemptions. So if you want thousands upon thousands of those negative preemption pods, like there is a point. I don't know where it is right now. Like it definitely changes between versions.
etcd, all the writes that you have to make for every pod update. I mean, it's generally.
I think even I don't want to go too deep on this. I think even on what I've seen in past was mainly in the kube scheduler layer, because the pod preemption path is actually sort of more complex than pod scheduling, because it does scheduling cycle and then it goes to preemption, and that's more costly to calculate. So I think you can basically just overload scheduler, I believe, with enough. You need thousands, and I don't know exactly how many, but I know there have been problems with that.
Yeah. Yeah, I mean, I think that the core idea for us, and this is something Jack was working on, was we have a requirements API, which essentially is you're able to describe constraints for nodes. And from our perspective, we were trying to figure out, whether or not users would want to define over provisioning at the pod level or at the node level. There's a whole other use case around over provisioning where you just over provision at your deployment level. So you set your pod autoscaler to a lower threshold so that you have more pods. And then any application side hydration logic that needs to happen, like warming caches or initialization or Spring Boot or whatever you need to do, that can also stay warm, if that makes sense. So we typically recommend to customers wherever possible to over provision at the pod level rather than at the node level. Obviously, there are some use cases where over provisioning at the pod level isn't possible. Like if you have batch jobs, maybe you don't know what work is coming in. But when you're at the point of over provisioning at the node level, we've been debating whether or not that even should be defined in terms of pods, or whether it makes more sense to define in terms of nodes using our requirements API. So for example, like instead of saying I want a pod that has 4 cores, you could say I want a node that has 16 cores, because I know that, I mean, it's essentially like who is the actor that's doing this over provisioning? Is it like a cluster administrator, or is it an application team? And which interface should they be coming in at?
That makes a lot of sense. And we had a lot of, I think, very similar discussions and very similar recommendations. I think this one, and like this effort isn't actually driven by cluster autoscaler developers as much as by the batch group in Kubernetes. I think it's a batch working group that's part of some SIG. I'm not sure which one. So this is basically them doing this because I think they don't want to, like, this is meant as an interface for higher level batch abstractions, I think. So the idea is because it's not going to be user doing this, but rather a more high level batch orchestra, like batch scheduling system, then it makes it easier because then you have a job and you can request resources for a job and have autoscaling, like node autoscaler layer be a kind of translation layer from pod to node, because it's already able to do this. And then all those batch frameworks built on top of Kubernetes may not be able to do this translation, or like may not have to. It basically feels like it shouldn't be in their scope. But again, I'm not very involved in this. I just read the cap and I kind of discussed it on very technical implementation level. But I think this is the driving use case. It's basically the desire to be able to do this from a higher level kind of orchestration mechanism on top of Kubernetes.
Yeah, I mean, if this ends up getting, is it going to be owned by SIG Batch or owned by SIG Autoscaling?
I think by SIG Batch, I think it's technically not SIG, but like whatever. Like it's essentially like Kubernetes batch group.
Yeah. Yeah, I think we should definitely get ourselves plugged in here, just because I think if it does become a standard upstream, then Karpenter customers will expect their batch schedulers to work with it. And it may be at odds with how we're thinking about over provisioning.
But at the same time, there may be a lot you can contribute to the design by sharing your experience. Yep. So, and that would be a good time to do it. Yeah. Okay, I'm going to move on to other stuff. So we have 2 config maps. There is status config map, which I just mentioned for completeness really, because it's a one-way read-only status information about cluster autoscaler. So I'm not sure if it's API service, especially because it's human readable. It's not really very parsable. We also have priority expander config map, which I think is something that's very needed for cluster autoscaler. I don't love the current implementation. It's basically for each node group, you can specify weight. And then when doing scale up, that gives you preferences. So I think there is equivalent of this in Karpenter, right? Because I believe you can set weights for provisioners, which I think is sort of very similar. but I think we need, as a cluster autoscaler community, we need a better API for this than the config map. I think we want some sort of CRD or something. So again, there may be some potential for some standardization around this. I don't know, maybe that's something that's worth discussing at some point, especially because we will be designing a new API. So it's not like we have an API we're already satisfied with. And then I think other things we have isn't really configured externally to cluster autoscaler. It's all different either flags or different options. I wanted to mention particularly kind of the things that you can configure for each node group in cluster autoscaler. So those are the flags that, or like the settings that can be controlled, but the way you control them is generally different on different cloud providers. It's basically, those are the settings, and then you set them in whatever way works on a given provider. And this is mainly, as you can see, scale down related settings. And so the threshold, I think that was mentioned at some point, that you may not want to delete node that's almost fully utilized, because you're just creating unnecessary churn, and then like timers around how quickly scale down happens. And then also how the utilization is calculated. And finally, timeouts for node startup. So this is currently the settings that can be configured per node group, but there is a lot of effort to move all of the flags where it conceptually makes sense that exist at cluster autoscaler level that today you can configure per cluster. There is an effort to move all of them to be configurable per node group. And especially everything that relates to scale up and scale down strategy, like those thresholds, delays, and stuff like this is being moved there. And then again, different cloud providers just add their own ways of configuring this. I think one thing I wanted to mention also is that we have gRPC API for external cloud provider integration also. So if you want to add support for a new cloud provider in cluster autoscaler, you no longer have to go and do all of the coding in cluster autoscaler repo. You can just implement an external component that just exposes this gRPC API, and then you're just going to be able to run cluster autoscaler. It's going to communicate with your component, and then your component is going to create nodes or do whatever else is needed, which is very much an API surface, though I think one where it would be very difficult to standardize, because it's obviously very much tailored for what cluster autoscaler is doing. So not sure if this one is in scope, but it's something we have.
One area we've diverged here on the utilization, scale down utilization and GPU utilization, is we decided to not do a utilization-based scale down. We just do a simulation-based scale down. So essentially, if there is a cost improvement that could be done through one of our consolidation moves, emptiness is very easy. Migration is also fairly easy. Like you could imagine a node is 100% full, but that node would, all the pods in that node would fit somewhere else. You can delete that completely full node. And so there's kind of enough cases like that where the utilization it's kind of hard to reason about in a super heterogeneous cluster. And so we decided to do everything simulation based, and the one parameter we've thought here is around an improvement threshold. So only make this move if it improves price by so much, as a way to avoid cases where you could save 10 cents to move from this EC2 node variant to that EC2 node variant, and you've saved price, but you've done a whole eviction cycle to save basically no money. And so I'm kind of curious, what is the utilization doing? Because I know that you guys are simulation based, but is the utilization essentially just a threshold? Like, do some customers set that utilization to 100 that says like everything is everything that could be scaled down, but gated by simulation, which is more or less Karpenter's behavior, or
you set it to 0. So yes, you set it to 100 to get this. Yeah. So exactly. So if you set it to 100, it's basically the same, purely simulation based. But if you set it to lower value, it's kind of a way for you to control the level of disruption, right? So I think it's similar, or the goal is similar to, I think, your kind of threshold of how much it improves price. It's just easier because pricing information is something we have in Cluster Autoscaler, but it's optional for cloud provider. It's hard to implement depending on the cloud provider, but like for many things, it's quite hard to implement. And so utilization is just easy. I think the price improvement one is a very nice idea. I think we should just implement it in Cluster Autoscaler, honestly. It's going to have this challenge again of we only have pricing information for cloud providers that implement it, which I think is less than half. It's my gut feeling is it's going to be about a third of them, but also I really don't know. I'm just making this up. So just based on like the code reviews I've seen for various providers.
You can model anything as price. It doesn't have to be true price. Like we used to do like a root mean squared of all the resources on the node, like the allocatable, just to compute like a value for price before we integrated with the pricing API. Pricing is super, super, super hard. I'm sure you have this at Google where some customers have private deals and you can't know that until the end of the month when the spreadsheets are rerun and there's no way to encode that logic. So price is always at best a proxy. And at one point we were modeling that via CPU and memory, just price was a function of the size of the node. Just thinking about like the current implementation, you could model utilization as price, which is kind of odd, but I think it would achieve your exact behavior if you essentially just called it's not really price. It's really like your optimization function for your
benefit, essentially. Like how much do you gain by doing this? Yeah, that makes a lot of sense. I think we're obviously going to have to keep the settings we have today for backward compatibility, but I think that's a very nice idea, and yeah, it's something we should look at. I look how the threshold exactly is defined, and again, maybe this is one of those things where we can sort of standardize on with some idea. If we can, I don't know how similar the algorithms are, but if we can figure out a way to kind of model those settings of the relevant subset of settings and just put that in some standardized API that works for every autoscaler, that would be awesome. I see there is a hand.
Yeah, my question is for Ellis. When you said Karpenter does simulation before and it sees which one would save the most cost and then scales down the nodes, is that simulation based on like a combination of scheduler simulation plus something else? I would imagine it would be something else as well. I was just interested in that.
Yeah, there's a whole bunch of stuff that goes into this. We call it our deprovisioning algorithm. It's actually being partially redesigned right now to improve the performance, because I think we're trying to be too perfect with an NP hard thing, and at scale it's kind of breaking down. But roughly we compute a set of candidates and essentially just sort the nodes by some function. Right now we actually use number of pods, so we try to because utilization is such a difficult function. But anyways, we sort a set of candidates and then we go through those candidates and say, if I were to delete this node, what would happen to these pods? And we use our scheduler implementation and we say, okay, most of these pods would schedule elsewhere. And then here's our remainder pods. Okay, if I had these remainder pods, what node would that fit on if we were to do our provisioning loop on? And then what's the cost of that node compared to this node that we're scaling down? So we essentially have a library that we can call and we say, here's the pods, here's the cluster state that we're modeling those pods against, and it spits out these pods will all schedule with 0 nodes, these pods will schedule with 5 nodes. these pods will schedule with one new node. And then it's just a matter of how do you pick the candidates and what order do you run the candidates through that algorithm. And we also have some like multi-node consolidation stuff, so we can simulate if we were to delete these 5 nodes at once, what would happen to them. And so that's useful for kind of minimizing the number of steps, because there's essentially a pathological case where you can scale down one node, migrate all the pods, then realize you can scale that node down, migrate all those pods, and then realize you can scale the next one down. You guys may run into this problem as well. It causes a lot of evictions and can cause deployments to run at the bottom of their PDBs essentially, which customers tend to not like. But did that roughly answer your question? I think that's a very high level of how the algorithm works.
That helps. I was just thinking this sounds very similar to what we do in Cluster Autoscaler today, and Maciej can correct me. I think we don't have the cost angle to it, which is very interesting.
Yeah, so Cluster Autoscaler is actually, I think in 127, I may be off by one version, so but in either 126 or 127, Cluster Autoscaler scale down was completely re-implemented from essentially what you described as single node simulation to multi-node simulation. And again, in kind of the spirit of being very frameworky and like provider configurable, the sorting function is something you can like, it's literally a Golang interface. And then the expectation is each provider is free to implement their sorting function based on whatever they like feel is a good way of doing this. And yeah, it sounds super similar. Like it's very similar algorithm based just on description. Just you have a sorting function, and then we have a like default one, and then customization. And there is this only like that big difference is the missing part with the possibility to create a smaller node, essentially, right?
Yeah, I think ours has a couple of other factors that includes the other node lifecycle details. So, for example, we have a concept of drifted, which means that the node is kind of out of spec. So if you change the AMI or if you change the requirements of the taints, all the nodes that were launched by that provisioner are now drifted and should be replaced at some point. We also have a concept of expired, which is a maximum node lifetime, essentially. So the node can only live for 30 days, which customers find really useful for security and some performance use cases. It's kind of the cattle, not pets mentality implemented in a single field. But the point being of you actually want to do those first before you do consolidation or before you do any scale down behavior, because often if you're expiring a node, the pods on that node would move somewhere else, and then you don't, like, your whole simulation has changed. And so it's, in a sense, it's almost like we have this kind of concept of trying to remember what Nick called them, but scale downs that could have a consolidating effect, but are more lifecycle based consolidations, and then other consolidations that are just purely for cost improvements. And so there's some kind of additional candidacy complexity based around, and there's an extensibility mechanism. So if you put the right status condition on your machine, we'll decide that machine should be scaled down, and it'll become one of these candidates. So there is a little bit of extra complexity that we realized that the lifecycle actions, and I think you'd probably find this as well if Cluster Autoscaler were operating against a node group that is in the middle of upgrading, is that your scale down decisions suddenly change drastically based off of that upgrade. And the upgrade, you might be upgrading a node group that has 10 nodes in it, and after the upgrade, now there really should be 4 nodes. And so there's some kind of complex interactions that you can take advantage of when you're doing both scaling and lifecycle in the same system.
Yeah. I think the difference again is kind of the lifecycle part isn't, at least today, the scope of Cluster Autoscaler, and so that's why we don't do that. You could do things like this with again all of the extension points. So if you're using a particular upgrade mechanism, you could build an integration like this. But the Cluster Autoscaler in general would be used with different, like on different providers, you expect different lifecycle mechanisms, existing ones potentially. So for example, a cluster API already handles upgrades, and so does GKE, and so do I think other providers. And then it's a matter of the scope of the project. But yeah, I mean, maybe extending Autoscaler to have like an option to do that would be interesting. That's I think a much broader discussion. Yeah, so that's all I had on cluster Autoscaler, but I'm happy to discuss any other questions. I have one unrelated point I wanted to quickly raise here. So if there are no questions, I would move on to that. And so this is completely unrelated to what I've been discussing before, but I've been wondering essentially as our group, right? Because it feels like a lot of stuff we're discussing with lifecycle and so on goes into maybe beyond what may be considered jurisdiction of SIG autoscaling, right? So I wonder, even if we come to some sort of idea for standardization, there is other SIGs which may feel that this is more their area of expertise. I think there is going to be, I don't know if it's more like SIG node, or like, I'm not even sure which SIG deals with node lifecycle, but I know that
SIG cluster lifecycle.
Yeah, exactly. So then like projects like cluster API and so on. Should we have them in this discussion? Because I think for purely auto-scaling part of the API, like the scale down settings that we've been discussing and so on, I feel reasonably confident that if in this group we come up with a shared proposal, I mean, I understand we're going to have to go to some API review process where maybe top level Kubernetes approvers will have some comments, but I imagine this is more about kind of having consistent APIs and so on, and more on, I imagine, how we implement this. But like if we do this, I feel like we have a position to have a strong opinion as a group. But then with those other things, like I don't know how much we can achieve without bringing those other groups. I honestly don't know. I'm just wanted to bring this up for discussion.
We definitely talked about it a fair bit. Or like whether or not is this a SIG cluster lifecycle thing, or is it a SIG auto scaling thing? And we agreed, okay, it's definitely both, but the current, I think Karpenter is closer to CAS than it is to something like CAPI. Like I think the more primary, well, it's kind of hard to argue because it really is both things, but all I'm trying to say is I agree with you. I think it's definitely crosses over into the concerns of cluster lifecycle. There's definitely some Conway's law concerns, right? Like we've organized the SIGs in this way, therefore the systems start to look like those SIGs. Yes. And I think because Karpenter was built outside of the SIGs, it wasn't necessarily subject to the same mental model or constraints. I just kind of, to the other thing I wanted to talk about, and which is exactly along these lines that you just pivoted to, was what is the form factor of this API? Like, is the form factor like a autoscaler configuration CRD, or is the form factor like a node group CRD, or is it a machine CRD, or like how do we? I think that the concepts are sufficiently different that I'm completely clueless as to where any of these fields might even live, and I think that deeply relates to the question of, is this an auto-scaling concept or is this a lifecycle concept? Because if we oriented around the concept of, like, we want to call the Karpenter provisioners node pools, like that's a cluster lifecycle responsibility kind of, or maybe that's like very much more clearly a cluster lifecycle concept, but that node pool CRD may not make sense in the cluster autoscaler world. Or I guess I don't really do, what's your kind of, in your mind when we're talking about this API surface, like what are you imagining the form factor is?
That's a good question. I don't have a very good idea of like final design yet. I hope we can reach this by starting with finding those are the things that make sense in kind of all contexts, the context of Karpenter and cluster autoscaler. And then now that we know we have maybe similar scale down algorithm, for example, we just call it differently. Right? How do we build an API for this that just kind of works everywhere? I certainly hope we can do at least 3 surfaces that I see. One is that's less of an API surface. It's more of a kind of standardization of behavior, like the thing we discussed with doing drain and so on, and ideally maybe all of the actuation just kind of behind the scenes. Again, less of an API, but would be very nice to have. The second thing I see is anything pod level really. Like if there is annotations, like anything we set on pods, there is no reason I think for this to be different. There isn't that much API service on pods anyway, and this is really the main API I think to both Cluster, Autoscaling, and Karpenter, right? You trigger things by creating pods. And then the final one is, okay, what settings we can, like what high level autoscaling concepts we can build an API, and this is kind of the real API in a way, the CRDs and stuff. What can we have that makes sense in both worlds? Again, I think things like scale down settings, for example, maybe some scale up settings, maybe things like the provisioning request, but that's a separate API. And that leaves an interesting question of a node pool API. I think in Cluster Autoscaler world, there is node group, which is essentially node pool. It's different name for the same thing. It's just for Cluster Autoscaler, it's more of a read-only thing, or most of it is read-only. In Karpenter, it's kind of different ownership, but that at least the fact that it exists and have basic things like name and can be modified in terms of size is shared. And so having at least some form of like placeholder is maybe too strong of a word, but like some concept of node pool somewhere makes sense. And then there is the part of this other responsibilities of Karpenter, which I think cannot be standardized with Cluster Autoscaler just because Cluster Autoscaler doesn't do those things at all, and they're essentially outside the scope of the project. To which I don't really have very strong opinion. I feel that part may be closer to cluster lifecycle space. But yeah, maybe we can structure the API in a way that you can still use the other settings without specifying those or making them essentially read-only in Cluster Autoscaler world. Not sure to what extent that answered your question.
Yeah, I mean, I think those 3 areas that you called out are really good. Just to echo them back, it's like cord and drain, the pod protection stuff, the pod annotations, and then like scale up, scale out, over provisioning settings, which is most of the business logic. I do wonder for the last one, maybe the opportunity is less around a CRD, just given the ergonomics of how the APIs work. It would be kind of weird to go through some interface that wasn't natural to both of the projects. Mm-hmm. And there may just be an opportunity for conceptual alignment. Like we call the fields the same so that it feels conceptually the same to the user, to ease migration, or to ease, you know, someone moving from one company to another can kind of experience it in the same way. If the company happens to be using a different autoscaler. But yeah, I guess at this point, I'm a little skeptical that there is I kind of feel like if we were to add that third, align on some sort of shared API for that third thing that was a literal same API, that it might reduce the functionality of both projects. And I guess I'm totally open-minded to someone proposing something alternatively, but I know Jack has had his hand up for a minute as well. I want to make sure he gets a chance to chime in, but I suspect we've talked about similar things around kind of lowest common denominator stuff.
Mm-hmm. Yeah, it's all good. I wanted to talk about, I guess, which SIG is the right SIG for Karpenter. I think to speak to your original observation, there is, I think, an inevitability in any SIG that you're working in that you're going to sort of evolve or innovate and collide with other SIGs. That's like a really common thing. I would imagine Cluster Autoscaler in particular, as it's defining pod annotations and those kinds of things is probably checking with SIG node to do sanity checks to make sure that, you know, there aren't, like, the lowest common denominator would be like a collision with a standardized annotation. Like, you can't do that, obviously. But I think a more common approach would just be like an integration sanity check. So for CAPI, so I'm a regular CAPI contributor. I'm a CAPZ maintainer. That's the Azure provider for CAPI. For CAPI, I think the approach for something like Karpenter would be an integration sanity check. So basically, how do we make CAPI work with Karpenter? And if you can't answer that question in a sane way that has, you know, high usability and UX and all that kind of thing, then that probably suggests maybe Karpenter should be a part, maybe like some of this functionality needs to be inside CAPI itself, because we can't find the integration story here. So that, I think that's a super useful exercise to do with things that naturally, so because Karpenter is an autoscaler and a provisioner, the provisioner aspects are going to have some overlap with standards or, like, you know, common patterns that are established by CAPI and SIG cluster lifecycle. So you want to have those integration touch points to make sure that the ways in which you're overlapping with those other SIGs make sense. Because you can't, I don't think you can avoid that. You know, the Conway's law stuff might be slightly overstated. In my experience inside the SIGs, things are not quite as organized as they might seem from the outside. I don't mean that as a criticism either. It's just like, this stuff is hard and boundaries are hard and sort of just inevitably loose. So the other point I wanted to make is that what was the other point I wanted to make? I lost track of my train of thought. Does this make sense what I'm saying to folks? Oh, I know. The most important point I wanted to make in terms of, like, where does Karpenter fit in terms of SIG cluster lifecycle perhaps versus cluster autoscaler, or sorry, SIG autoscaler. I think the sort of where the rubber meets the road in terms of SIG cluster lifecycle is control plane cluster upgrade type behaviors, and Karpenter really has no overlap there whatsoever. So that, to me, actually suggests, unless I'm wrong about that, feel free to interject, Ellis, but that suggests that it's actually a poor candidate for SIG cluster lifecycle. So we've been talking about CAPI as a kind of metaphor for SIG cluster lifecycle, but there's actually a ton of stuff in SIG cluster lifecycle. And I would say the common thread there is like cluster upgrade, cluster configuration. So like control plane orchestration, that kind of thing. Worker node innovation is not really there. It's obviously part of a cluster. And so it's hard to like strictly define like a node is not a part of a cluster. You know, that's like clearly not true in practice if you're a cluster administrator. Like your nodes are definitely an intrinsic part of the cluster. But if you're like, you know, in an academic setting, defining the separation of concerns of the Kubernetes architecture, the control plane is sort of like the fundamental set of properties that define the cluster. Nodes kind of come and go. Nodes can be joining from different regions, from, you know, those are more sort of ephemeral configuration attributes of a cluster. But the control plane, like my Kubernetes control plane running 128.2, that's the key part of the cluster. And so if all that makes sense, that's what SIG cluster lifecycle is. I think that's the common thread from all the projects. And certainly CAPI is super, super involved in that. One of the key initial stories for CAPI was making cluster upgrades easier, you know, reproducible, all that kind of thing. So I would say, in my view, it's like it's not sort of like 50-50, like could be SIG cluster lifecycle, could be SIG autoscaling. It's more like 90-10. Like there is some case to be made that this could be a SIG cluster lifecycle, but I think it's kind of a poor case. Not to say that wouldn't be, if, you know, if there's no path forward in SIG autoscaling, I think SIG cluster lifecycle would be a sane fallback.
I think I've lost audio as well from you, Jack. I'm guessing that's what Alice was questioningly looking at.
Yeah, I can hear you guys, but not Jack. I lost him right at the end. Yeah, I mean, I think just to continue that point around cluster lifecycle, I think broadly, like the node lifecycle behaviors have not been owned by the Kubernetes project. They've been owned by the cloud providers. So like you have the node pool service in GKE, the node group service in EKS, and then a whole bunch of, kind of like KOps has a whole bunch of node lifecycle behaviors. I know that like Weave has done a bunch of work in that space, but there hasn't been a ton of, there's not really like the core, there's the nodes themselves, but the node orchestration is kind of been left to the cloud providers individually to implement before Karpenter.
Yeah, so just to clarify my comment, I'm not saying we shouldn't be doing this in SIG autoscaling. I just meant that I would hate to spend a lot of time writing some CAP or some proposal just to learn that actually this goes contrary to some like other plans, or we haven't accounted for some work of other SIGs that I may be completely unaware of. So I meant it mainly from a sort of risk mitigation point of view of us investing a lot of time and then learning that there is something. But maybe like it seems there is a lot more knowledgeable people in this group. So maybe this is all accounted for, in which case I think we're good.
I think it's a great call out. Really, really good call out. And I think you suggested maybe looping someone in from other SIGs. I think sometimes that's appropriate, but in my experience, the best way is for a SIG like this to drive that collaboration. So, we need to keep ourselves honest as if we're talking about SIG autoscaling, the folks in this SIG need to be aware when topics have ramifications in other SIGs, and then drive that, invitation in to make sure, hey, this is what we're doing. Can you give us a thumbs up, thumbs down? Or it's a great call out though. It's going to be a continual process of doing that, I think.
Thanks. Okay, and I just wanted to quickly go back to earlier comment by Alice. So I think that even if we don't get to an like a single CRD as you kind of mentioned, lowest common denominator type of issues, I think there is still value in us trying to make those as you basically described. Like even if we just renamed fields and make similar set of fields, I think there would already be value in this, because I think when we discuss scale down in cluster autoscaler and then consolidation in Karpenter, there isn't very much difference, and I think the differences that exist would be reasonably easy to bridge. And so just by renaming things or like finding common names, making the settings similar, again, like different types of thresholds, we could, I think, go a long way towards making it much easier for the users to reason about this. So yeah, I think it's still worth giving it a try, even if we decide that, yeah, we cannot do a single CRD. That's fine. Let's make it as easy on the users as we can.
Yeah, totally. We are 6 past the hour. Do we want to talk next steps? I know that from our side, we have some work to do with SIG architecture to go bring our beta proposal, all of our APIs. Those are we're in a feedback period for those right now. On the SIG autoscaling alignment front, it sounds like there's maybe like a drain kept that needs an owner. And then there's also, still look at my notes here, maybe there's a place that we could collaborate on the pod level annotations, and just I know Jonathan has been trying to define like the our concept of safe to evict. And then we need the namespace for that, whether it's like node lifecycle.kubernetes.io or anything else. What do you think about, I don't know, as the SIG or maybe Jack, I know you have a bunch of experience across the project. What do you guys think about next steps for making progress on this?
Do we have communication points with the SIGs that we want to collaborate with, like architecture in particular? Do we have velocity there?
Are you in touch with anyone, Jonathan?
Not at this point, though. It was kind of a bit of a question on the V1 Beta 1 API, since we were not planning to put that into a Kubernetes-based namespace, at least immediately, my understanding. I think that was more of like a forward-looking proposal, right?
I can definitely help with that in September, early September when I get back from leave. If you don't want to wait until then feel free to just dive into the deep end. And I don't, off the top of my head, know the exact path how you do that, but sort of,
yeah. I mean, I think
tangentially, I'm super happy to hear that we're doing that.
Yeah, I think we can definitely drive it. Like I can take the action item to drive it forward. I'm not so convinced that like we'll get. I don't know, Alice, you can tell me if this is wrong or you don't feel like this is like the right path forward. But in my mind, like the V1 Beta 1 API was going to get settled outside of the SIG architecture review, and we would think about the SIG architecture review for like future API versions.
Yeah, no, I agree with that. I guess the point was more like the node lifecycle namespace, Kubernetes namespace. I think the sooner we get moving on that, the better. I think we had all discussed last time that that's probably where this stuff belongs, including maybe even like the safe to evict stuff for the pods. Since you're communicating about, I mean, for all we know, like maybe upgrade should respect, and it does in Karpenter, whether or not safe to evict is true, or expiration also respects it in the same, it's kind of like a PDB override in a way. But I think that there's potentially room to get moving on the node lifecycle namespace now, and I see that as a collaboration between Karpenter and SIG Autoscaling. And then we could also, we could say aspirationally, we want to move to Karpenter. We want to move the Karpenter APIs into this namespace as well, not right now, and I wouldn't block it on it. But that maybe like if we can make that node lifecycle namespace, and then we can make progress on the coordinate stuff with respect to that namespace, and progress on the pod annotations with respect to that namespace, and that's kind of where that's the new container for things essentially. Does that make sense to everyone?
I think my thought was mainly that we need to align on this discussion before we go to SIG architecture, obviously. So we need to understand all the things that Maciek like brought up today, like how we're going to define them as a group, and then we go to SIG architecture after that.
Yeah, is it worth just emphasizing that these collaborations with SIG Autoscaling in particular should be happening? We're not gated by a decision whether or not Karpenter is going to join SIG Autoscaling, because even if that ends up being a negative, we would want to align on that. Is that everybody thumbs up on that approach?
Yeah, if Karpenter doesn't join SIG Autoscaling, but there is API surface and a node lifecycle namespace, we would integrate with it.
Yeah,
I think I agree with that.
Yeah, cool. I mean, it sounds obvious, but maybe, I don't know. I just want to make sure that we're not unnecessarily waiting for this sort of like blessed, okay, you can join SIG Autoscaling and now we can get to work. Let's get to work now and then let the process play out in parallel. And
from a like Karpenter joining perspective, like what do we see as gating that? I mean, I don't want to put you guys on the spot, but like what's the like Guy, how is that process evolving from your perspective?
To me, it feels like if we have those discussions of agreeing what we want to go forward to SIG architecture with, that feels like we are basically agreeing the criteria that sort of the SIG put out as the criteria for Karpenter joining. Like it feels like we are very much aligned on the areas where we want to provide that common experience to users of either of the projects. To me, it feels like if we drop that dot to the point where we're happy, where both sides are happy to go to SIG architecture with that, that to me feels like the criteria is being fulfilled. Obviously, Marston's been off the past 2 weeks, but the recordings will be up so he can review etc. But need to run it past him when he's back. But I'd be slightly surprised if there is a negative there. So yeah, I think it feels like to me we, as people have said, we should be working on that alignment to go forward to SIG architecture, and then I think once we've got that document in a place, we're happy. We can have that next step of conversation about, does Karpenter become a SIG Autoscaling project?
Okay, so do we want to maybe write like a brief doc to present SIG architecture, and we can talk about the new namespace as well as the 3 kind of areas that we're interested in putting into that namespace. Does anyone want to collaborate on that doc? Maybe I can just post it to the group, or we want to assign an owner to that. Is that something you're interested in, Maciek, or would you prefer we lead it?
I'm very interested in general in taking part in this. I'm not sure what the scope of the doc you're proposing is. I'd love to do, because right now we've been having a few meetings, and we have some, I think, high level thoughts. I would like to try to, at least for something, just try to like translate this into some very like design type specific thing, just to prove that the concept is working, because we've been doing a lot of hand waving, and I like just to try pick some area and just try to solve this. And if anyone is interested in this, I'd be very happy to collaborate. I think in terms of like, I don't know, this is quite a big group. I wonder if an efficient way to approach this would be to have a kind of smaller subgroup, do a first draft, and then we can discuss it, because I think just drafting in a large group is not the most efficient process.
Yeah, so the artifact is essentially a distillation of this discussion, maybe try to map concretely the fields and take a pass at like what we might want to name things, and just have kind of the core concept to talk to them about what we're exploring, maybe not as official as a KEP, but something concrete about, framing the discussions we've had so far.
Yeah.
I think from ownership from our side, it's probably either myself or Jonathan. We can get back to you over Slack on who that is, and presumably from SIG Autoscaling side, you want to take that on, Maciek, or is there someone else?
I'm happy to. I'll be off just for a few days in this kind of this and early next week, but it's like 2-3 days here and there, so I just may not have a great response latency, and I may not be on the next meeting. I'm not entirely sure yet.
Okay, great. So we can plan to maybe skip next week and get into drafting mode.
Sounds good to me.
Sounds good.
Yeah. So let's follow up on Slack then on the details and start working there. Bye. I need to drop now. Thanks everyone. Bye.
Thanks everyone.
Thanks.
Thanks everybody.
Yeah.
Yeah.